guys, so here we go. We finished seeing all of our exponent rules. And like I said, the rules individually are easy. It's when you have to use them all together, like maybe a problem takes 3 rules to get to your answer. That can be confusing. And then just don't forget, we will forever and always have to abide by PEMDAS, right? All right, so at the top of your notes today, I just put all of the rules in one spot for you guys to have them to reference. So remember, rule number 1 says when multiplying the same base, we add exponents. Rule number 2 says when dividing the same base, we subtract exponents. Rule number 3 says when one exponent is raised to another exponent, we multiply exponents. And guys, that's it. Those are the only 3 things you're allowed to do with exponents. You're either adding them, subtracting them, or multiplying it. But that's it. The 4th and the 5th rule, these are like our fix-it rules. If you get down to the end of a problem and something has a negative exponent, this is how you fix it. You move it from top to bottom, bottom to top. And then the 4th rule, the 0 exponent rule, said anything raised to the power of 0 will always equal 1. Just pay attention to who's being raised to 0. Everything or just something. All right, so I'm actually going to do the notes very, very backwards. I originally had taken 3 examples right out of our book, but then I took 3 examples right off of Delta Math because that's where your homework is going to be. So I actually want to skip to examples 4, 5, and 6 because they literally say the word delta next to them because I took them right off Delta Math. And that's exactly what your homework tonight is going to look like. So let's do those 3. We can save these problems for another day. So I'll go over those 3 with you, and then you guys can start working on your homework. So go to example 4 first. Okay. Oh, I went too high. All right, so here's example 4. I'm actually going to do example 4 with you 2 different ways. I like to give you guys options in case somebody prefers one way over the other. I really do truly believe you're going to like the first way better. But like I said, I want to give you an option. It may be something that we could use in the future that helps us when we're working with exponents. All right, so guys, look at example 4. Ultimately, this problem is saying to take the top and divide it by the bottom, right? But I definitely can't divide it yet because the bottom is stuck inside parentheses that I know I have to remove. PEMDAS would say, go to the parentheses first. So the top has to stay. 4y to the 6, c to the negative 8. I can't use it yet, right? And we're going to try and divide that by, what do we get on the bottom? Well, guys, everything on the bottom is being raised to this power of negative 3. Now, I know I've told you that negative exponents are bad. However, negative exponents to me are only bad if they're in your final answer. If they're in the problem, guys, we can work with them. We can add them if we have to. We can subtract negative exponents. We can multiply negative exponents. I just work with them, and then if anything still has a negative exponent at the end of the problem, we'll fix it. All right, so on bottom, inside the parentheses where PEMDAS would tell us to go, guys, everything's being multiplied together. I can't multiply that together any more than it already is. So I'm going to look to the outside. On the outside, there is a power of negative 3 that says everything on the inside has to get that power. So let's give it to everything on the inside of these parentheses. But guys, be careful, because 5 is a number. So when you give him a power of negative 3, that literally becomes 5 to the negative 3. And you straight up cannot do that right now. That is going to have to be fixed to become 5 to the positive 3. Believe it. That's what he is. We can't do it yet. We're going to have to fix that eventually. All right, now continue giving that power of negative 3. So now I'm going to take y to the negative 2, give him another power of negative 3. So that's power to power. We multiply exponents. That'll be y to the negative 2 times negative 3 is positive 6. So guys, it's not even a negative exponent anymore. All right, and then you're going to take c to the negative 3, give him another power of negative 3. So again, that's power to power. So we multiply our exponents. Negative 3 times negative 3 is positive 9. So guys, at the end of the day, my bottom exponents aren't even negative anymore. All right, so now it's a division problem, right? And we're like, oh, division's easy, not bad. It usually isn't bad. But guys, we have a problem. This damn 5 to the negative 3rd. He's going to be the death of us. So I would advise you, because of that 5 to the negative 3rd, because we're going to have to fix that, don't do your numbers yet. Leave 4 over 5 to the negative 3. Leave it for the end. We'll fix that. Let's get everything else cleaned up. Let's get our y's figured out. Let's get our c's figured out. Let's simplify the rest. All right, so guys, if you look here, in a division problem, you are supposed to subtract your exponents. But guys, it's even easier than that. In this problem, you end up taking y to the 6, and you end up dividing it by himself, y to the 6. What do we automatically know anything divided by itself is in math? 1. So really, the y's to the 6, they literally divide out of the problem. Y to the 6 divided by himself, y to the 6 is 1. And if I put a 1 in here, 1 times 4 is 4. 1 times 5 to the negative 3 is 5. It doesn't change anything. So you don't even have to write the 1. It's gone. And even if you did your subtracting exponents, 6 minus 6 would be 0. You'd get y to the 0. Who's y to the 0? It's 1. So you literally, the y's are gone. They've divided out of the problem. All right, now we get to our c's. We subtract exponents, right? So the bigger exponent is 9. So my answer is definitely going to go back on the bottom. Take 9, subtract negative 8, the little exponent. It turns to addition, and you get 17. And it goes back on the bottom where the bigger exponent was. So guys, there's not a lot less for us to do. It's kind of a small problem right now. The only thing that we got to fix right now is our numbers. This 5 to the negative 3, he can't stay there. I need him to be 5 to the positive 3. So if he's 5 to the negative 3 on bottom, where's he going to have to go to become 5 to the positive 3? To the top. So when you move him to the top, he used to be division, but when you move him to the top, now he'll be attached to the top by multiplication. So the 4 was already there. Now you're moving this up, so now it'll be 4 times 5 to the 3rd, divided by, there's no reason to move the c to the 17. He's beautiful where he is. All right, and again, when something gets moved from the bottom to the top or vice versa, it's literally going to be connected to whatever you moved it to by multiplication. All right, well, guys, now multiply or an exponent. PEMDAS would say to do an exponent. 5 to the 3rd is 5 times 5 times 5. Guys, that's 125. So 4 times 125 is 500 over c to the 17. And that is a finished problem. And let me tell you why I know it's finished. Number 1, I know it's finished because I don't got any negative exponents looking at me. I got no negative exponents in my answer because you don't want them. I also know it's finished because I no longer have y's on top and bottom. I no longer have c's on top and bottom, so that's all simplified. And the number itself, 500 over technically a 1 here, doesn't divide or reduce anymore. So this is definitely a finished answer. Okay, so that's one way to do this problem. I'm going to show you another way, and we're going to get the exact same answer because that's the beautiful thing about math. There might only be one answer, but there could be different roads that take us to that answer. And I just want to show you this. Number 1, somebody might like it better, but it could be something that we might need in the future. So watch this, and I'm only going to do this once. The other problems, I swear, I only do once. Look at this problem a different way. And again, maybe you just want to watch this one. It's up to you. Here's another approach. So like I said, right now it's a division problem. Take the top, divide it by the bottom. However, I can't divide yet because the bottom is inside parentheses. I got to get rid of that. So maybe somebody thought of this. Guys, the entire bottom, the entire problem is being raised to a power of negative 3. So right now, you could say to yourself, well, if this entire thing is raised to a power of negative 3, where could I move the entire bottom to make that a positive power of 3? I can move it to the top. So technically, I can turn this into a multiplication problem. So my top stays. I can take the entire bottom, move it to the top. And I said, when something gets moved to the top, now it will be attached by multiplication. And it will be 5y to the negative 2, c to the negative 3, all raised to a positive power of 3 now. Now again, a lot of students are like, wait a minute, you moved this up and you didn't make these ones positive? Guys, I can't. The reason I moved this up is because that outside exponent was negative. These exponents, you got to think of them, guys, they are stuck inside the parentheses right now. You can't get to them. You can't move this up, change those, and change that. That's not how it works. I can only change the one on the outside, the one I can get to. All right, so now it's a multiplication problem. But before I multiply, PEMDAS would say to do exponents. So all of this has to get that positive power of 3 first. So this is going to come down again. And I'm going to multiply with whatever I get when I give everything inside a power of 3. So guys, this is a 5. It's raised to a power of 3. Now that's 5 to the 3rd. 5 times 5 times 5. There's that 125 that we got over there. All right, y to the negative 2 to another power of 3, we multiply. That's y to the negative 6. C to the negative 3 to another power of 3, power to power, we multiply. C to the negative 9. Okay, so now we're going to multiply. Numbers with numbers, y's with y's, c's with c's, and we'll add our exponents. So 4 times 125, there's that 500. Y to the 6 times y to the negative 6 is y to the 6 plus negative 6 is 0. And then c to the negative 8 times c to the negative 9 is c to the negative 8 plus negative 9 is negative 17. So now look at all this. All of this is on top. Guys, who's y to the 0 going to become? 1. So who's 500 times 1? 500. And it's still being multiplied with a c to the negative 17. But guys, I ain't leaving that as my answer. Where does the negative 17 is only on c? So where does c to the negative 17 have to go to become positive? To the bottom. So 500 stays, and you move c to the negative 17 to the bottom. And you get the exact same answer. So again, I will be the first to say, I definitely think you work harder for your answer this way, but it's definitely an approach you can take. And we may have to do stuff like this in the future. So I just wanted you to be aware that that is a possibility. I do think that this is a little bit more straightforward, and I'm about 99% sure that if any of you, do any of you use Delta Math's help? Like they'll show you how to get the answer sometimes. Like after you've gotten it wrong, you can see the work. I'm 99% sure this is how they're gonna walk you through the problem if you got it wrong, okay? All right, so that's that. So now we have 2 more examples from your homework. I'm only gonna do them this way. I want you guys to do number 5. Get a head start. I'll start to do it slowly after you started, and we'll start checking to see how we're doing. So guys at home, start number 5. If anybody gets stuck, just raise your hand, we'll help you. Again, I'm gonna give you a little bit of a head start, and then I'm gonna slowly start filling things in, and we'll start checking to see if we're at the same spot. I know, right? Yeah, I start and end my day with like my biggest group, like 2nd and 7th period. So.
Yeah, I just end my 6th period classes off the rails today. Like they would not stop talking, but I wasn't even mad about it.
Ooh, I could never get mad. Everyone
Oh, I wasn't even mad.
Yes. So I'm having you guys try number 5 right now. Exactly. So now the bottom stays because we haven't done the change yet, and give everything inside of here that power of negative 3. Yep. So guys, the parentheses are usually a dead giveaway. It's kind of where you have to start because PEMDAS would say to do parentheses first. So right now, just to give everybody a heads up, you should be taking the top and giving everything inside that power of negative 3. And the bottom will stay the same right now. That's how we should start. At least doing it this way. So if you want to check, there's my new numerator when I gave everything inside of the parentheses a power of negative 3. So guys, that 2 to the negative 3, he's going to haunt us. Leave it. We'll worry about it in the end. So now it's a division problem, but I think you should leave your numbers. Just worry about dividing your variables. Get all the y's and n's fixed first. Right? Leave your numbers. Figure out the y's and n's. And then guys, for me, don't forget, -5 is the bigger number compared to -12. Remember, as negative numbers get closer to 0, they're actually getting bigger. And -5 is closer to 0 than -12. So he's the bigger exponent. Remember, I'd rather be $5 in debt than $12 in debt. I take a peek at me. Let's see if we have the same variables. I have a y to the 8th on top and an n to the 7th on bottom. And now I can figure out, all right, what's the deal with my numbers, right? 2 to the -3 is going to have to become 2 to the +3. And the only way to do that is to move them to the bottom. And remember, when you move them to the bottom, they'll be attached to what's down there by multiplication. Go ahead, Angel. Oh, so now y to the 8th will stay up top. 2 to the 3rd is going to have to go down, and then it'll be multiplied with the 6 n to the 7th. So now y to the 8th, he's just chilling up there. He's good. 2 to the 3rd, guys, I can do that now. That's 2 times 2 times 2. That's 8. And now 8 times 6 is 48. And then n to the 7th is just hanging out. And now I know that's a done problem because number 1, I got no negative exponents. That's great. I have y's only on top. They're not on top and bottom anymore. I have n's only on bottom. They're not on top and bottom anymore. And my number 48, guys, technically there's a 1 over 48. Those numbers don't divide or reduce any more than what they already are. So that's definitely a finished problem. How do you guys feel? Is everybody okay? Yeah? At home, can I get a thumbs up? Okay. All right. I'm going to ask you guys to start number 6. I think number 6 is the easiest problem here, and you'll see why. Try 6, and then we'll be good for the day. And again, I took these right off of your homework. Is it a hand or, I don't know if it's the chat or the hand ever.
It's me.
What's up, Jack?
For number 6.
Yes.
I can't see the bottom
Okay.
number after the. It's like kind of really tiny.
So. How's that?
Good. Thank you.
Yep. So again, we're going to go to that denominator. Go ahead. The parentheses are where we should start. But guys, if you notice, 2 is not in the parentheses. So he's not part of what's getting that power of -5. That -5 is only going to the C and the B. The 2 is just waiting, hanging out to be multiplied with what comes out of here. So you shouldn't end up with a number raised to a negative exponent in this problem, which is great. It's going to make this very, very doable. Go ahead, Angel, what you got? You all right? So our top should stay. We're working on this part of the problem right now. So 2's hanging out. We're given the power of -5 to the C and the B to the 3rd.
Alright, so you're going with 8, that's fine. Take down here, you're good with that. And that you wouldn't have. So it just, you don't distribute that in, it just stays there. The only thing you're gonna do is what you did with this. Okay?
So guys, this is what your bottom should become, right? You give the power of -5 to these two pieces. So you get C to the -5, B to the -15, and then you're timesing that with 2. Guys, there was no number in front that you had to multiply with the 2 when it came out. So it's just going to be 2 times the C to the -5, B to the -15. And it's not like you have to distribute the 2 because there's no adding and subtracting. You'd only have to distribute 2 if there was adding and subtracting.
What's your bottom?
Oh, beautiful, beautiful. So you stop. The reason why you stop is 3 things. Number 1, no negative exponents.
Yes.
Number 2,
power to power,
you have
yes.
C's on top
So
and
negative
B's
5
on top.
times 1
There's no
becomes
C's
C
on
to the
bottom
-5.
and top. There's no B's on bottom and top.
negative 5
And then your
times
number
3
2 has
becomes
nothing to divide or reduce.
B to the -15.
You just don't need
I
the
would
lines in
have
that.
that, I don't know where you got.
I can't mark you wrong for putting it, but
This was.
You started out strong here, you're good.
Yeah.
okay, so now,
To the negative.
because
to
you
the-
have your parentheses are gone, you have no numbers
Right,
raised, you
and
have
now
negative
what
exponent,
you wanna
now you
do
just
is
straight up divide.
Start
So
getting
4 divided by
more,
2 are your
whether
numbers,
you're
4
gonna
divided by
top,
2
or you wanna
is
move
2,
the top and bottom
and
and
whole
do it
numbers
that
always
way.
go to the top, so put a 2
Okay.
in the line, under. Alright, now we do our C's. So big exponent minus little exponent, and it'll go back on the top. So 3, subtract negative 5, turns to 3 plus 5, which will be 8 on the top. Now, remember, it's not on 2, it's on C, it's C to the 8, right? That's a constant. Okay, and then your B's, you have 4, and you have negative 15, so 4 is the bigger one, so your answer B will definitely go back on top, and then it'll be 4 subtract negative 15, which turns to plus.
Okay, so then what you wanna do, you
Is
can
19,
just
it's back on top.
move all your negatives to the top, and then start combining them.
That's it.
Do your subtraction.
You don't have to have a lot.
So that's it.
Done.
Thank you.
Alright, so we get here.
Oh, you were just right.
The good news with this problem is, like I said, here, you didn't end up having a number get raised to a negative exponent. So everything was doable, right? I have 4 divided by 2. That's normal. Let's do that. 4 divided by 2 is 2. Whole numbers always go to the top. And then now it's division. Subtract your exponents. 3 is bigger. So 3 subtract 5 turns to plus. You get 8. It goes back on the top where the bigger one was. So C to the 8. 4 is bigger. So take 4 and subtract negative 15. That turns to a plus. You get 19, and they go back to the top. So guys, everything went back to the top. Nothing survived in the denominator. So now you don't even need this line, but if you wanted to, you could put over 1. But denominators are allowed to be left empty. It's only the numerator that has to have a 1 if it's empty. And guys, you will know you're done. 3 reasons. Number 1, I got no negative exponents. Number 2, I don't have C's and B's on top and bottom anymore. They are simplified to just one spot. And then my number 2 has nothing to be divided or reduced with. So you're done. Go ahead, Kyle.
So there's a number like an exponent on the top and like say it to the bottom or like.
Wait, start over. Let me get my head straight. Okay, start over.
So like if an exponent's like on the top or the bottom and then you like switch it to go on the like opposite of where it's at,
Mhm.
it changes the sign.
So if I was to move C to the negative 5 to the top, it'd be C to the 5th.
Okay.
Yeah, because you could also do this, Kyle. 4, C to the 3rd, B to the 4th, over 2, C to the negative 5, B to the negative 15, right? You could do 4 divided by 2 is 2. You could say C to the 3rd stays, and C to the 5th comes up, and then you add those exponents, and you get 8, right? And you could say B to the 4th stays, and B to the negative 15 comes up, and then you add them and get 19, if you want to do that. I just leave them where they are and subtract. Because if you subtract in the correct order, they'll always turn positive and put them back where the bigger one was. But you could also do that.
That's what I was saying.
So I was getting -2 and -1.
Yeah, he was just subtracting,
Yeah.
like, and getting
Like,
3 minus 5.
Okay. Now again, Kyle, if that's the case, let's say for some reason, let's say you did negative 5 minus 3 and got negative 8 and put it back here. That's fine. If you have C to the negative 8 in the end of the problem, just move it up. You know what I mean? Okay. All right. So guys, you have a new homework tonight. I think it's 7 questions on these types of problems. Every problem should take you at least 2 rules to get to the answer. Last night's problems are due tonight though, so make sure you got those done. Tomorrow I'm going to give you a review, and then Friday I'm going to give you a quiz, just like tomorrow's review. All right, people at home, if you don't have any questions, you are good to go. We'll see you later, and then if anybody needs my help here, just let me know.
Kyle, you can remember